This lesson is on factoring polynomials. Factoring methods, these are review. So these four types of methods: common factoring, trinomials, difference of squares, and grouping. You already have learned those. Common factoring, we also just call it the greatest common factor. Well, let's start with the first one, common factoring. This is first on our list because we always look for a greatest common factor first. Don't forget to do that first. Looking at the question here, what is the greatest common factor? So we look at the numbers first. We've got a 24 and a 4. So the greatest common factor for a 24 and a 4 is a 4. Now we look at the x's. We've got an x to the power of 1 in the first one and x to the power of 3 in the second, so they can each have an x divided out. And y's, no, we can't take it any y's because there's no y's here. It's got to be common, right? Common to both, and that's not, so we can't take any y's out. So then I open a bracket, and remember that factoring really means dividing, so I'm really dividing this by a 4x. So 24 divided by 4x is just a 6, and then subtract, so dividing this by a 4x, and we get x squared y. So that's just greatest common factor. Let's try B. What's the greatest common factor? We'll look at the numbers first. So we've got a 9, a 3, and a 6. What factor do they all share in common? And if they didn't share anything, we wouldn't put a 1 down because 1's not really, it's just always assumed to be a common factor. But these have a 3. Now we look at the a's. We've got an a squared, an a, and an a squared, and we can only take out what's there. We can't take out any more. So this one only, the middle one has a single a, and that's as much as I can take out of all of them. Even though the other two have a squared, I can only take out as much as what's there. So I can only take out an a. And now we look at the b's. We've got a b squared, a b, and a single b. So we have to go with the smallest that we can go with, and that's a b. We take out that greatest common factor. Again, that's like dividing. So we divided it out of the first term, and we're left with a 3ab. Divided out of the second term, and we are not left with 0. We're left with 1, because 3ab, negative 3ab, divided by 3ab is, well, it's a negative 1, but it's just a 1, right? We can't put a 0 there, and we can't just ignore it. And then our last term is going to be a 2a. So those are factored by using greatest common factor. Take a look at the answers here. Notice that the greatest common factor, which is a monomial, so other than the greatest common factor, sorry, this is the greatest common factor, monomial, this is the greatest common factor, monomial. The remainder of the expression is enclosed in brackets. An expression is factored when all polynomials are enclosed by brackets. So here's a non-example. So this is a wrong way to do it. If you look at this trinomial and you say, oh, I'm going to take a 5x out of these first two terms, take out a 5x, I'm with x minus 2. That's not factored because there's a plus sign sitting out in the open. It is not factored because all terms are not enclosed by brackets. And I can tell that by looking at it, but also because of this plus sitting out here, right? That's clearly not enclosed in a bracket with the 1. Trinomial factoring. There's a quick way to identify if you'll be using easy trinomial factoring or not, and you ask yourself 2 questions. So let's look at an example and see these 2 questions. We've got 2 examples here. So look at the first one. We're going to ask ourselves question 1. Are there exactly 3 terms here? 1, 2, 3. Yes, there are exactly 3 terms here. Question 2. When written in order of descending powers and a common factor has been eliminated. Okay, so is there a common factor here? No, there isn't. I can't take a common factor out of these 2. Remember, I just talked about that. So there's no common factor. Does the first term have a coefficient of 1 or not? So here's my first term at the front. In order, it does have an invisible 1 there in front of it. So this does satisfy the easy trinomial factoring. The first thing we're going to do is look for a greatest common factor. Okay, we just did that and there isn't one. Now we identify it as an easy trinomial, and that's by looking at the steps 1 and 2 that I circled. So we know it's called an easy trinomial because our leading coefficient, our coefficient in the front, this a, is a 1. So I know it's called an easy trinomial. You don't have to use the word easy, but I'll explain why I'm using that later. Okay, so we know it's an easy trinomial. Now what we have to do with it is find two key numbers. These key numbers have a product of C and a difference of B. What are those letters coming from here? Well, they're coming from right here. I'm circling them here. There's your B and there's your C. So I'm taking, in this case, C is the 12, B is a -1. So I'm looking for two numbers that have a product. They multiply together to give me -12, but they also add or subtract to have a sum of -1. So what two numbers do that? We'll call these key numbers. What are the numbers that multiply to -12 and add or subtract to -1? So that would be a -4 and a 3, because -4 times 3 is -12 and -4 plus 3 is -1. Since this is an easy trinomial, that means I can go right to writing my answer here. All I do, actually, let me put your steps up, set up brackets with the square root. So let me first set up two sets of brackets. And the square root of the first variable at the front, so the square root of that part. So we're putting an x at the front. And at the end, the key numbers go at the end. So here's my key numbers over here, my -4 and my +3. So I'm just going to put -4, +3. So those are my 4 steps to easy trinomial factoring. Let's try that again with part B. All right, back up to step 1. Are there exactly 3 terms? 1, 2, 3. Yes. Number 2, when written in order, so it's in order. We've got p squared and then p and then the constant goes at the end. So when they're written in order of descending powers and a common factor has been eliminated, okay, does the first term have a coefficient of 1 or not? Well, right now it does not. The first term right now has a coefficient of 3. So let's go back and look at number 2. It says, and common factor has been eliminated. So do we have a common factor here? And we do. We have a common factor of 3. So let's take that out first. So I'm going to divide a 3, not a p, just a 3. I divide a 3 out. I have p squared plus 3p minus 10. So now I'm going to look at this trinomial right here. Does it have a coefficient of 1? Yes, it does. So this p, now that I've factored out the 3, has an invisible 1 in front of it. So that means we can look at our 4 steps on the side. So step 1 is look for a greatest common factor. Okay, we already did that. So we did that. Identify it as an easy trinomial. So that really refers back to this number 2 here. It's an easy trinomial if our a value is a 1. So our trinomial means these 3 terms here. In this case, we're using these 3 terms. And our a value that's in front of this p squared is a 1. So this is an easy trinomial. Now we're going to find 2 key numbers, sum and product. And you might have learned other methods last year. You might have used the terms crisscross or maybe just decomposition. But what we're looking for 2 numbers that have a product of -10 and they have a sum of 3. If you know the crisscross method from last year, you can go ahead and do that. You don't need to do it the way I'm doing it here, although it's very similar. So are there 2 numbers that have a product of -10 and a sum of 3? So once you figure out those numbers, let me write them down here. What 2 numbers have a product of -10 and a sum of 3? That's going to be a 5 and a 2, right? So 5 and a 2 multiply to 10 and they add to 3, but I want to get the sign right. Which one's positive and which one's negative? The 2's got to be the negative because I've got to end up with +3. So now I'm going to factor my trinomial. And I'm on step 4 now. So I've got 2 sets of brackets. The square root of the first term goes at the front, that's a p. And at the back, go my numbers that I just figured out, which one's a +5 and the other one's a -2. So that's how we factor easy trinomials. And really when you do it, it's a lot faster. I just went through the steps very slowly here, but when you're doing an easy trinomial, you'll be doing that, like question A, you should be able to do that in, less than 30 seconds for sure. Difficult trinomials. So that's why I call the other ones easy. These ones are difficult trinomials. They have a coefficient other than 1 in front of the x squared term. So they have an a value that's not 1. A is not equal to 1. 6x squared plus 7x minus 5 is an example. Because I don't have a common factor, I can't factor at the 6. The 6 is still there. So my a value is a 6. So this is a little harder, a few more steps involved. We're going to use a method of decomposition, which is also parallels with the sum and product we just talked about to factor this question. Again, if you already know how to use crisscross, you can go ahead and do that. Step 1, look for greatest common factor. We already discussed this. We don't have one. Step 2, so we identify it. We know this is a difficult trinomial. I can't just do the quick method that I did before, and I know that because of that 6 in front there that I can't get rid of. So this time we find factors of a and c. So what are a and c? Here my a is at the front and my c is at the back. So I'm looking for numbers that multiply together to give me 6 times 5, that multiply to give me -30. And they have to add or subtract, this step is the same as before, to give me 7, +7. So what are two numbers that multiply to give you a -30 and add or subtract to give you 7? So that's probably going to be a 10-3 combination, right? So how would we get a 7 out of a 10 and a 3? This one has to be negative. And we know we need a negative because there's a negative sign right there. So 10 times -3 would give me that -30. So we've got our two key numbers here, +10 and a -3. That's step 2, or step 3. Let's look at step 4. We use these key numbers to decompose the middle term. And decompose, again, if you are doing this with crisscross method, or you're doing it, when I was in high school, I just had to, I kind of did it with a trial and error. We didn't do decomposition. But I'm going to go through decomposition because it's just methodic. It's kind of an algorithm. We want to decompose the middle term. The middle term is a 7x. So I'm going to break it down. That's what decomposing is. I'm going to break it down with those two key numbers that I wrote there in purple. So instead of 7x, I'm going to write that as a 10x and a -3x. And if you have one positive and one negative, if you have a choice, put the negative first. It makes it easier later. So all I've done is taken the 7x and rewritten it as -3x plus 10x. The rest of the question, so the first term is going to stay what it was, 6x squared, and the last term is still -5. So these two lines are equal. I need to put an equal sign here at the front because those lines are exactly the same. If I were to collect like terms, I'd be right back where I started with the 7x. So why did we do that? Let's look at step 5. Step 5 is now grouping. We have 4 terms here, so I'm going to group them with pairs, and I have a plus sign in the middle, which I need. That's why I said if you have a choice between the positive and a negative, you put see this is a +10, you put the plus in the middle. Those brackets should not be touching. You have to be careful of the signs. So if there were a negative, you would have to pull it into the bracket and write your own positive sign in the middle. We have to have a positive sign there. Okay, so that's grouping. Now, each pair of brackets here has a greatest common factor. The first one has the greatest common factor of 3x. When I factor out a 3x, I'm left with 2x minus 1. And when I take the second group, the common factor here is a 5, and I'm left with, surprise, surprise, exactly the same thing, 2x minus 1. So let's look at step 7. Notice the brackets themselves are greatest common factors. So what that means is when I look at, this is one big term because we're multiplying all this stuff together. This is another big term because we're multiplying the 5 with the 2x minus 1. So those terms each have a greatest common factor of a 2x minus 1. Now these brackets have to match. If they didn't match, then we made a mistake. So basically what I'm doing here is I'm taking out a greatest common factor of a 2x minus 1. And when I factor that out, all that's left is a 3x plus 5. And you could have written the brackets in the other order if you wanted to. But the 2x minus 1 comes out because it's the greatest common factor. And we can check that with FOIL. What is FOIL? We talked about this in our last lesson. It's the distributive property. So we're going to distribute. We're going to check by distributing. So we're going to check here. I'm going to rewrite out the question. 2x minus 1 times 3x plus 5. I want to check to see if that's right. And I'm going to check it by multiplying 2x into both of these brackets here. That gives me 6x squared plus 10x. And now I multiply the negative 1 into both terms in the second bracket. That's negative 3x minus 5. We have some like terms here in the middle. So we have 6x squared plus 7x minus 5, which is the question we had originally at the very beginning, right here. So I know it's right. Example 2. I'm going to put the steps in here again for you. You don't have to have the steps. You don't have to refer to the steps all the time. And if you already know how to factor trinomials and this is just tedious for you, then I suggest you just press pause and you do the factoring yourself and then press play when you're done, and you can skip ahead until you get to the answer to see if we all get the same answer. So step 1, remember that was look for a greatest common factor. Do we have a greatest common factor? Better take a look because it looks like it's kind of complicated, this one. Let's look at the numbers first. 8, 26, and 7. Well, no, there's no greatest common factor there. So let's look at the letters. M cubed, M squared, and MN. Yeah, there's an M that is common here. So let's take that out first. Take out the greatest common factor of a single M. We're dividing out an M. That leaves us with 8M squared minus 26MN minus 7N squared. Now, identify it as a difficult trinomial. Now, this is harder than before because we have two variables, and in the last one we didn't have any variables. So imagine for a minute that the n's weren't there. Imagine this was not here and this was not here. Then that would match our trinomial that we did before. The first term is squared, the second term has just the m, and then the last term is a constant. As long as that works, oops, I erased the whole thing. I'll have to go back and rewrite that. N. As long as the same thing works in reverse, meaning you've got an n squared here, a single n here, and no n's here, then it matches the pattern of a trinomial that we can factor using decomposition. So this is a difficult trinomial. Our leading value there is an 8 that's in the brackets. So it's not an easy trinomial. I'm going to have to go through those steps of decomposition. Find factors of a and c, which also have the sum of b. So two numbers so I'm going to multiply these two together first. So I'm looking for two numbers that multiply together to give me a negative 56. And they also have to add or subtract to give me the middle number. That's a negative 26. So think about that for a second. Did you figure out the numbers? You might have needed your calculator for a bit to go through some factors of 56. So what are two numbers that multiply to 56 and add or subtract to 26? So 56 divided by 2 is 28. So 28 and 2 are good contenders here. We need a negative 26 though, so one of these has to be a negative. It will have to be the 28. There's our two key numbers. Step 4 is to decompose the middle term with those key numbers. So I'm going to take that 26mn and I'm going to rewrite it using the 28 and the 2. And remember that if you have a choice between a negative and a positive over here, we're going to put the negative first. The negative will go first. That way we'll get a positive in the middle, which we need in between the brackets. So this is negative 28, and my letters have to match. mn, negative 28mn plus 2mn. And then the 8mn just comes down. 8m squared, and the negative 7n just comes down negative 7n squared, and that's all in a bracket, and we still have our greatest common factor m in front. Those two lines are exactly equal, so you have to have an equal sign. One equal sign per line. Be sure of that. Next step. Group the first and second pairs. Be careful of the signs. And I have to be even more careful here because I have already a set of brackets. So I'm going to put in another set of brackets here. The first two go together with brackets, plus sign in the middle, and the next two go together in brackets. So I've got my greatest common factor of m in the front, and what's my next step? Greatest common factor each set. I'm going to change this bracket right here, these round brackets at the ends, I'm going to change them to square now. So that's a square bracket. It's supposed to be a square bracket. Do that again. Square bracket. So out of that first green pair of brackets, what's the greatest common factor? It's a 4m. So when I factor out a 4m, I'm left with a 2m minus 7n in that one. Now the next pair of brackets, the green pair, the only common factor there is an n, so I take that out. When I divide that out, I have 2m minus 7n left. And close that bracket, and then there's my square bracket at the end. And of course, my brackets match. If they don't match, then the factoring didn't work or I made a mistake. So let's continue with, I've got my greatest common factor of m here. And I have my square bracket. So I'm going to pull out that common factor bracket set of 2m minus 7n. When I pull that out of this term, I'm left with a 4m. When I pull it out of the second set, I'm left with a plus n. So that is our, let me put our step 7 up there. The brackets themselves were the greatest common factors, so we factored those out. And I don't really need the square brackets anymore because I've got everything is all factored. It's all done. So I can keep them attached with regular brackets. I don't need to encompass them in square brackets. So that's good enough. And then our last step would be to check to distribute. We're not going to do that this time, but we would have to distribute everything all together, and then that would give us our original question. And it's great to do on a quiz or a test to do that check step, because then you know that your answer is right or wrong, and then you fix it. Difference of squares was another one of our factoring methods from last year that we're going to review. What do you notice about this form that would help you to identify a difference of squares polynomial? So what we notice about a difference of squares, first of all, it's got the word difference in it, so we need to have a subtraction sign in between them. The other thing is there's two terms. It's a binomial. Two terms with a subtraction sign between them. And both terms, both are perfect squares. So that's how we identify a difference of squares. So just like when we did the trinomial, we had to identify it first. So we need to identify a difference of squares. Factoring a difference of squares is easy. You just take the square root of each term, set up brackets, one with a plus sign, one with a minus sign. So let me start with the easiest type you can get, part A. Is it a difference of squares? So first, is there a subtraction sign between them? Yes. Are there two terms? Yes. 1, 2. Are both terms perfect squares? Yes. So I can do a difference of squares here. So what I'm going to write out is exactly what it says when it says this is easy. So I set up two sets of brackets. One with a plus sign, one with a minus sign. It doesn't matter which one gets which. We take the square root of the front term, that goes at the front. We take the square root of the back term, that goes at the back. Done. That's difference of squares. And you could multiply it out with binomial expansion to see that it truly is x squared minus 9. Next one's hard. So we started with an easy one. The next one's harder. Is it a difference of squares? So this, although it looks like several terms, this is all connected with multiplication and the power of 2. It's all connected together. So that's one term. There's another term. So is there subtraction between them? Yes. Are there two terms? 1, 2, yes. And are they both perfect squares? They are, because this 9 at the front is a perfect square. I can take the square root of 9. I can't take the square root of a 5 or a 2, but I'm not going to because all I need is this power of 2 here. I'll be taking the square root of that. Let me erase that, and then I will show you the steps here. So we set up two sets of brackets. I'm going to use square brackets because there's already round ones there in the question. Two sets of square brackets, one with a plus sign, one with a minus sign. The square root of the first term goes at the front. So what's the square root of that? Well, the square root of 9 is 3. And the square root of anything with a power, the radical and the power just cancel each other out. So I'm left with 2x minus 5. I have to move that minus sign over there, I think. Minus. Okay, same thing on the other side. 3 bracket 2x minus 5. And then at the back goes the square root of y squared, and that's a y. So although that is factored, we usually don't leave it like that. We simplify a little bit. So I'm going to distribute that 3 in, just so I don't have too many levels of brackets. That gives me 6x minus 15 minus y, and 6x plus 15 plus y. Now you might see in the back of the book those brackets rearranged in order to put the x, then the y, then the constant. But since this question is just testing the factoring, you don't need to show me that there. You can stop there. Part C. Okay, does this match? Can we identify this as a difference of squares? Do we have two terms? Yes. 1, 2. Is there a minus sign between them? Yes, there is. Are they both perfect squares? Yes, they are. Because anytime you have a variable to an exponent that is even, as long as that is an even number, you can take the square root of it. So x to the power of 22, the square root of that, we divide by 2 and we get x to the power of 11. X to the power of 100, the square root of that is going to be, so I'll write it out, it's really 100 over 2, so it's x to the power of 50. So as long as you have an even exponent, we can divide by 2. Now you probably didn't realize that before because we usually just had x squared and you would just say the square root of x squared is x. It is because 2 divided by 2 is 1. So back to, let me erase my mess here and let's get back to our question. What is, so we start off with two sets of brackets. I don't need extra brackets, I just need two sets here, no square brackets. Square root of the front term goes at the front. So that's going to be a 9x to the power of 4 at the front of both brackets. One gets a plus sign, one gets a minus sign. At the back, we put the square root of the second term, that's a 4y to the power of, whoops, this is not 9x to the power of 4. Sorry, I was looking at my last exponent there. I was looking at this exponent. X to the power of 4, that's a 2, because that's half of 4. And I just gave away my answer. The square root of y to the power of 8 is y to the power of 4. Whoops. 4 minus 4y to the power of 4. Okay, looks good, right? Well, we're not quite done because this bracket right here is another difference of squares. Not this one, because it has a plus sign in there. So it's not a difference of squares. But the second one is. So we need to continue factoring. The first bracket, I can't do anything with that. It's tempting, but I can't factor that any further. So I'm just going to rewrite 9x squared plus 4y squared to the power of 4. And now I'm going to set up two more brackets because I have to break down, break down that second set of brackets. Right now I'm working on this one right here. Square root of the front term, that is a 3x at the front, 3x, 1 plus sign, 1 minus sign. Square root of the back term is 2y squared, 2y squared. Do we have any more differences of squares? The only one that could be, the only one with a minus sign is this one. Is that a difference of squares? No. 3x is not a perfect square, neither is 2y squared. So that's the end of the line for that question. Now the last one we're going to talk about is factoring by grouping. And we already did that when we did our decomposition. We already had 4 terms, and then we grouped them together, but those worked out nicely. So here I have 4 terms. So I want to throw brackets around a pair. But I want to pick a pair that has something in common. So if I just put my brackets right here where they sit, like that. Now I need a plus sign in the middle, so I have to squeeze that negative over there and put a plus sign in the middle. Okay, if I group them like that, I don't have any common factors here, so I'm going nowhere with this. So that's not a good pair. So sometimes you might pair things up that actually don't work, and then you want to try something else. So let's put something together here. What does go with the AB? Well, really either of the other two. So let's try the negative 5a. Put those two together. And then, so I'll put a bracket there. We need a plus sign in the middle. Next bracket. We have a negative 35 and a positive 7b left over. So let's see if this is going to work out for us. Next line, I'm going to take out the greatest common factor out of the first bracket. That's an a. When I factor that out, I'm left with b minus 5. What's the greatest common factor in the second bracket? It doesn't look like it's going to match, right? But I can take out a 7. I can take out a 7, and then I'm left with a negative 5 plus b. Are those brackets the same? Is b minus 5 the same as negative 5 plus b? Yeah, it is. All I need to do is rearrange this, move them around, and it's the same thing, and I'll do that. So b minus 5 plus 7. So I'm just going to, my b is a positive, and my 5 is a negative, so I can rewrite it like that. Once again, I have a big piece here and a big piece here, and they both have a common factor, a bracket of b minus 5, so I'm going to take that out. And now my brackets touch because everything is factored. Only when your brackets are touching are you done factoring. And you could check that by expanding. Okay, next one, our last one. Our last one is, again, 4 terms. So I'm going to ignore the little hint that I wrote there for a second. And let's say I thought, well, I'm going to group these together here, like this. Well, I can take an a out of the first bracket, but I can't take anything out of the second bracket. Second bracket's a difference of squares, but I need brackets to match. Like over here, I've got a b minus 5 matches a b minus 5. And that's the goal with factoring by grouping, is that you get brackets that match so that you can finish factoring. Those won't match like that. So I might try a few other things, grouping things together, and I would find that putting them in 2 and 2 isn't going to work. So this time, I try a couple of pairs, they don't work. I'm going to try 3 and 1 instead of 2 and 2. The first 3 terms are an easy trinomial. So that's sum and product. So I need 2 numbers that multiply together to give me 9. They also have to add or subtract to give me negative 6. So what does that? Well, a 3 and a 3 will multiply to 9 and give me 6. But I need them to add to a negative 6. So they both need to be negative, because negative 3 times negative 3 is positive 9. So this factors to a minus 3 times a minus 3, and then I have my minus b squared here. Well, that's not looking great. That is not factored because I have a minus sign sitting out in the open. It's not enclosed in brackets. But I'm just going to take that a minus 3, and I see that there's 2 of them exactly the same, so I can write it like this. And now what I have is 1 term, 2 terms that are both perfect squares. They have a minus sign between them, so I have a difference of squares. So I'm going to factor again, this time with a difference of squares. So I'm going to factor again with a difference of squares. So I start with my equal sign. I have to set up two brackets. So since I already have brackets, the two brackets I set up are going to be square. One of them gets a plus sign, one of them gets a minus sign. Doesn't matter which one. The square root of the front term is going to go at the front. So this whole term is squared. So the power of 2 is canceled out by the radical. That leaves me with a minus 3 at the front. And the square root of the back term, b squared, goes at the back. That's just a b. And I will tidy that up to get a minus 3 plus b times a minus 3 minus b. And that's factored because all the brackets are touching. So everything is completely factored there. So there's your review of all of the factoring methods that you learned in grade 10.